All right. So, okay. So first and foremost here, let's discuss what we have to do with the problems here. Okay, we are finding roots for quadratics, but we're doing it in that new method called completing the square. It is not the quadratic formula. So if we go to my first example here and we take a look at it, this is like the first type of problem that we have. Okay, something like this. Okay, let's say that that's my problem. And I want to find the roots for it. Well, previously, things we've done previously is where you had to identify where A, B, and C is. A is here, B is here, C is here, and then you had to plug in the negative B plus or minus square root thing. We're not doing that, right? Because that's the old stuff. What we're doing now is that new method called completing the square, where you can solve it using basic algebra 1 mixed with a couple new steps. Now, the problems I'm going to provide you today will give you a kind of a real sense for the types of problems I'm going to give you. You're going to have a couple easy ones right off the beginning, and then you're going to get one that looks something like this, where we've never done one of these before, but it has a leading coefficient out front. We've never dealt with one of those. I want to show you how to handle this situation today. So, when you do this problem, okay, I'm going to rewrite this problem up here, so we have a little more room to work. I don't like it right in the middle. All right. So what we need to do is we need to get rid of that number out front before you start, because if you look back at all the problems we've done up to this point, we never had to deal with one that had a leading coefficient. Here's how you do it. Number 1, is your problem in descending order?
Yes.
Is it set equal to 0?
Yeah.
Then we're ready to start. Question, sorry.
Can you pull out a common factor?
Yes, and that's what we're going to talk about. On this particular problem, since you have a leading number out front, you want to divide everything by that leading number, which is your common factor, exactly right. I want to divide everything by the leading number, which happens to be the common factor, and that's usually how they always kind of work. So you're absolutely right. I'm going to divide everything by 5. Everything. Because if I divide the left and the right side by 5, you will have a normal looking quadratic. X squared plus 10x plus 3 equals 0. Because 0 divided by 5 is still 0. That's a normal problem. And you're absolutely right. You want to do a common factor.
Thank you.
Okay, now we want to just do the completing the square method. So the completing the square means you have to move over that constant to the right side. I want the 0 on the right. I'm going to move the constant over there. What happens when I move the 3 over? It becomes negative. So it becomes over there, it'll be 0 minus 3, which is negative 3. Okay, questions? And again, if you're at home and you want to unmute yourself and ask a question, don't be afraid, just unmute. You can even type it in the chat, I have the chat open, so if you want to type in the chat too. So.
You muted it.
What?
I said you muted the chat last time.
Well, if it gets out of control, I mute it. And then I subtly unmute it when it's question.
I don't know. So
Probably wasn't invited.
That was the best.
It was my freaking idea and I didn't get invited.
Okay. All right. Hey, shh. Let's keep continuing. So now here's the rule. We have to take half the middle squared. So the middle term, if you look back at the original problem, this one that after we got rid of that common factor, the middle term is the 10. We have to take half of it and square it, which is 25, and that's what we're going to magically add to both sides. We are literally making that number up. How we make that 25 is you are taking half the middle, which is 5, and squaring it. And that's the number you're going to magically add to both sides. Now, why we can do this is still a balanced equation. We're doing an addition property of equality. By adding it to both sides, the equation is still the same equation, because I could just subtract it back and it's back to normal. But why we do that is because the left side will factor perfectly. How this works is every time you do this, the left side will factor up into 2 parentheses that exactly match. I don't care about this right side. Those are just digits. I don't really even care about them. I'll do them later. But the left side should always work out to be perfect. This will be x and x, plus and plus, and you're absolutely right. It's going to end up being 5 and 5 because of the numbers you picked. Here's my shortcut to you. The numbers in the parentheses will always be half the middle. What was the middle term again?
10.
10. Half of it's 5. Those will be the numbers in the parentheses. That is guaranteed. That's the way we made it. We made it so that the 25 was made of 5 times 5. That's why it was half the middle squared. Now, the definition of an exponent tells you this, that you can place both of these parentheses together and just put a power of 2 on it. And then I actually did the math on the right side over there. This is what you want to get down to. This is the whole point of completing the square. You want to make those parentheses match so that you can combine them using that definition of an exponent, and then you want to solve for x. And this is that process that you use, that you take the power to the other side and you do a square root on that side. So this is the square root plus or minus of 22. And it's always plus or minus. The reason being is that square roots always have a positive or negative number because it doesn't matter which number you pick. And now square root of 22, it's like 4 point something, 4.7, 4.6. Square root of 22, 4.6, 9. So doing the math here, so this ends up being, roughly about 4.69 with a bunch of decimals after it. And I'm going to subtract the 5 across, and so this ends up being x is equal to -5 plus or minus 4.69. And that's where you can see both roots. And this is where I would hit the x-axis. It's going to hit at, what is that, 0.3 something, 0.31. -5 plus 4.69, which is negative 0.31, and, hold on, negative 0.31, and it's at negative 9.69. -5 minus 4 more. So, all right, but those are the two roots, right? Now that is not the Google form question. That is not it. But this is what we're doing in the homework. This is what I want to get down to in the very end. I want to see those decimals in the very end, that you know what we're getting to. Now, some might. They probably won't be. When you do this method, they'll be decimals usually. All right. Anytime, the only time that they'll be nice clean numbers, if you didn't hear Hassler, that's only if it's factorable.
Right.
Okay. The problems I picked are not, because I just made up numbers. So how this works is why this is the process. I know that we divided 5 out earlier, right? I took the 5 out. I took that common factor out. All that affected on my picture was where I hit the y-axis. It didn't affect where the roots are. And that really messes with people, because this graph actually did change a little bit. If you were to graph the part that I did, the x squared plus 10x plus 3, and compare that to the original thing I had in that weird bluish color at the very top, the pictures will look different, but the x-intercepts won't be. Because all I did was make it taller, but it still hit the same x-intercepts. So that's something kind of unique to a problem. I know that really throws people off. It's called a scalar. It just makes things taller on a graph. It doesn't necessarily affect the width at all. So, all right, questions? Yes.
I have a question. It has nothing to do with math. I just have a
Okay.
question. When you shave your beard, do you like make the line, or does it just grow in that like?
It just kind of grows that way. Yes.
What?
Underneath?
No, I have to shave that pretty clean.
What do you mean by line?
Like right on his cheek, it's like perfect.
No, that's just where hair grows.
Whoa.
Okay. All right. Anyway.
That wasn't bad.
Okay. All right. Now I'm kind of weirded out. All right. Moving on.
I would be too.
All right. Moving on. Okay. Example number 2. This is the Google question of the day. Same thing. I want to find the roots for the second problem. Now, let me clarify what's going to happen on this problem. This problem is not written in the correct order, and we're going to have an odd number on it in the middle. This will have decimals kind of all over the place. I'm going to show you a way to avoid decimals. You can use decimals, don't get me wrong, it won't make a difference. Your answers will be almost exactly like what mine are. But the way I'm going to show you how to do this will avoid having to use one of these. So it's my kind of go-to method, because I don't want to have to pull out the calculator. Maybe I can't even find it. So if I can avoid using this at all cost, maybe this is the method you want to do. Again, I made this problem such a way that we're gonna get a weird odd number in the middle. So if I rearrange this thing, here's what we have, because it's not in descending order. So it's x squared plus 3x minus 2 equals 0. Now it's in the right order. So now I can start this whole process of completing this square. Question.
If it's not in descending order on the homework, do you want us to write it?
Yes, I want you to rearrange it.
Okay.
I don't know if you'll even have to. Okay, so moving on. Let's move that 2 over to the other side first. Okay, so if I move the 2 over, it becomes a positive. All right, now, what we have here is we have that weird odd 3 in the middle, because this is the moment where I have to take half the middle squared, right? And I know half of 3 is 1.5, and you square it, and it's like 2.25. Fine, whatever. I don't need that. I don't need the decimal. So here's how I want you to avoid it. If you take half the middle, you just write it as a fraction. This is half the middle. It's the middle divided by 2, right? That's half the middle. And then I'm going to square it. And that's what I'm going to add to both sides. By writing it like this, I don't need a calculator. I don't care that it's 1.5. It's just 3 divided by 2 squared, right?
Sure.
And why this is important is you'll see it here in a second that it works out nice and pretty when you just write it like this. You don't actually write the decimals. So when I do this, when I work this out, this works out to be 3x. This is 9 over 4 because you have to square both the top and bottom number. Over here, same thing. This is 9 over 4, which is still 2.25. Right, that's 1.5 squared. And when you go to factor the left side, right, because you have to factor that left side apart, it's not hard. If you remember, what was the shortcut I told you earlier when you factor the left side? It's half the middle number. If you remember that rule, you don't have to worry about decimals. Because when you factor this apart, it's x and x, it's a plus sign and a plus sign, whatever half the middle is. Well, half the middle was 3 divided by 2. That was half the middle.
So what would happen if you accidentally put that 9 over 4 in there?
In the parentheses, that would be wrong. It's always half the middle because you have to factor it apart correctly. So that's my little shortcut is it's always half the middle. That's what's going to be in both parentheses. On the other side, I have to make sure that I add these fractions together if you're going to do this method. If you're going to do it this way. Otherwise, if you do decimals, you don't have to worry about this. But like off to the side, I'd be adding 2 over 1, this is what I'd be doing in my head, plus 9 over 4. I'd be adding those off to the side in my head. I have to get common denominators when I add fractions, so I have to put a 4 on the bottom. If I multiply the bottom by 4, I have to multiply the top by 4, so that turns out to be an 8. So 8 plus 9, that turns out to be 17 over 4. That's how you add fractions, right? You get the common denominator, add the tops. If that's too much, just write down the decimal. It's 2 plus 2.25, that's 4.25 on the right side. You can write that. You can write the decimal. I'm totally fine. I'm just showing you a way to do it without using decimals because I don't want to have to do it. Now, the left side here, I can combine this down to one simple root, or one simple parenthesis, I should say. Not a root, but a parenthesis. And now I'm going to do the math that we just talked about in the last. I'll take the square root to the other side. So this is what it looks like. So if I take the square root to the other side, it's plus or minus whatever the square root of 17 divided by 4 is. That's 4.25. It's the square root of that number. And then the last step is to move that 3 halves over. So if I move the 3 halves over, here's what I come up with. This is the final answer, right? It's negative 3 halves plus or minus the square root of 17 over 4. Like that's my 2 roots. Now, obviously, you're waiting for, well, Ward, what's the Google answer? What do you need to type? I need the decimals. So you'll have to go to the fractions anyway. You'll have to go to the calculator. So 17 divided by 4, that's 4.25 on a calculator. I'll take the square root of that number. So 17 divided by 4 is 4.25. I'll take the square root of 4.25. So this turns out to be, if I was doing this math, this turns out to be 2.06. That's plus or minus negative 1.5. So these are the numbers I'm going to be entering into Google. when I type this in. Negative 1.5 plus 2.6, 2.06, and then negative 1.5 minus 2.06. And those are the numbers that I'm going to be using here. So negative 1.5 plus 2.06. What is that? That's 0.56. And negative 1.5 minus 2.06, negative 3.56. Those are the numbers everyone was kind of waiting for. These are the Google form questions. You're going to have at least one today that'll be odd. So you'll get some decimals.
So in the end, we're going to need a calculator.
Yeah, you'll need a
Do you have
calculator.
a Zoom right now, or are you just recording?
No, I got a Zoom. I got a bunch of people in. So, all right. Is there any questions with the methods or the work? Okay, I'm going to leave that up on the board. For those at home, make sure that you are, if you have questions, you can stick around, you can ask away. For those here, you still have to fill out the Google form question of the day, even though you're here, as opposed to being at home as well. Make sure you fill that out. These are the 2 answers I want. Homework is already on. It should be on Google. It's a worksheet. It's 5 questions. Put it on a separate sheet of paper. Take a picture of it. Submit it to me. I think grades are up to date. The only thing I didn't grade from last week was Friday's homework. Sorry, I didn't get to it this weekend. But I put in everything else. If you notice, maybe like, hey, Ward, I turned in a worksheet like a week ago, or maybe 3 or 4 days ago. I emailed you and you never got it graded. It says LI in the grade book. Just let me know. I'll get it graded. I went back and I tried to type in some names so people are still owing me something, so I could go back and fix some stuff. But, you know, it's simple error. I just missed your email. Didn't look at it. I was searching. I had somebody come in early this morning. They had a missing score because they didn't put their name on the paper. There was only one of those, so you don't have to worry about it. It's already been claimed. But it might be just something like, oh, yeah, I forgot to turn in, you know, worksheet 1.7. I think that was the thing to do Friday. Or something like that. Make sure you're getting those things turned in.
Can you put that score in? I got F.
Oh, yeah. I'll get to
It
it.
was 100%.
I'll get to it here right before we're done. So, all right. But yeah, so for those online, you guys can log off. You can go answer your Google form question. Unless you got questions, you can stick around, ask away. But I'm gonna stop the recording here. So,
Hey Ward,
what's up?
is the